So, what is actually happening inside your head right now that allows you to experience, well, this? It's pretty much the biggest question there is. What is consciousness? Today, we're going to dive into a pretty radical theory that says the answer isn't just in your brain cells, but in the fundamental laws of the universe itself. I mean, really think about your own experience for a second. You're seeing these words on the screen, you're hearing my voice, maybe you're feeling the chair you're sitting on. How do all of those separate signals, processed by literally billions of individual neurons, somehow come together to create the single unified experience of being you? Neuroscientists actually have a name for this. They call it the binding problem. And it's one of the biggest unsolved mysteries in all of science. Our standard model of the brain, as a kind of biological computer, it just completely falls apart here. It can't explain how all these separate, fragmented bits of information get bound together into that single, coherent movie of reality you experience every waking moment. So what if the answer isn't in classical biology at all? What if the reason we can't crack this mystery is because we've been looking in completely the wrong place? This is where a wild new theory comes in, proposing that the solution lies in the strangest, most fundamental part of science: quantum mechanics. Now, this is a huge shift in thinking. The classical view sees the brain as a network of individual parts, kind of like wires and switches. But the quantum view suggests something completely different. Imagine your consciousness isn't made of separate little pieces at all, but instead it's a single, unified quantum wave, a field of potential where all information is connected globally, all at once. But hang on, if you know anything about quantum physics, you're probably already spotting a massive, glaring hole in this whole idea. In fact, it's a problem that, for decades, has stopped theories just like this one dead in their tracks. And here's the central conflict. Quantum states are unbelievably fragile. For them to even exist, they need perfect, cold, isolated environments. But the brain? It's the exact opposite. It's a warm, wet, electrically chaotic storm, an environment that should destroy any delicate quantum state in an instant. This is known as the decoherence problem, and it has always been the killer argument against a quantum mind. So, how does this new theory possibly get around what seems like a fatal flaw? Well, it makes an absolutely incredible claim that life, over billions of years of evolution, has become a master of what the source material calls quantum vacuum engineering. It has evolved to solve this exact problem. And this brings us to the idea of defense in depth. The theory argues that our biology isn't just passively quantum. It has actively engineered this ingenious, multi-layered shield specifically to protect these fragile quantum states from all the chaos going on inside the body. And this shield isn't just one thing. It's a biological system made of 3 incredible layers, all working together: a dielectric shield, a spin filter, and a collective antenna. Okay, let's break down what each of these do. Okay, layer 1 is pretty wild. Inside our cells, the cytoskeleton organizes water into this really special gel-like state, and this creates what are called exclusion zones. These zones act as a natural shield that literally pushes away all the thermal chaos. You can think of it like biology's built-in noise-canceling headphones for quantum states. Next up, the spin filter. Many of our core biological molecules are chiral, which just means they have a specific left or right-handedness. This creates a really bizarre quantum phenomenon called the CISS effect. It's kind of like a perfectly efficient one-way street for electrons. They can only flow forward, which means no energy gets lost as heat. This keeps the whole system incredibly stable and cool. And the final layer is just incredible. In our cells, dense arrays of an amino acid called tryptophan all act together like a single giant quantum antenna. They have this unique ability to absorb all the random, chaotic energy from their environment and then re-emit it as one stable, coherent beam of light. They literally turn noise into a crystal clear signal, creating the robust quantum state needed to run a quantum brain. So, biology has built this incredible quantum fortress inside our cells, and it's capable of holding a stable quantum state. But why? What's the ultimate purpose? This is where the theory takes a giant leap, connecting it all to the very nature of time, gravity, and consciousness itself. So consider a famous clue from neuroscience. Experiments by Benjamin Libet back in the 1980s discovered something pretty unsettling. Your brain shows activity for a decision about half a second before you are consciously aware of even making it. There's this 500 millisecond gap. But what if that delay isn't a glitch? What if it's the entire point?
This brings us to the legendary physicist Sir Roger Penrose. In quantum mechanics, a wave of possibilities has to collapse into one definite reality. Now, the standard view says this collapse is just caused by random noise and it happens instantly. But Penrose proposed something far more elegant, that the collapse is actually caused by gravity itself. It's not random, it's a predictable process that's baked right into the fabric of spacetime. And, crucially, it isn't instantaneous, it takes time.
And this is the absolute core of the entire theory, that 500 millisecond delay. The theory proposes this is precisely the time it takes for the brain's massive, protected quantum state to reach a threshold where gravity itself forces it to collapse into a single reality. That physical collapse doesn't just happen during a conscious moment. It physically is the conscious moment. It's the universe defining one single frame of now. Now, I know this all sounds like some mind-bending philosophy, but what makes this so compelling is that it's a real, testable, scientific hypothesis. The researchers have actually proposed some very clever experiments to see if any of it is actually true. For instance, they propose testing whether anesthetic gases work by physically disrupting that quantum light inside our microtubules. They suggest swapping key atoms in an organism's brain with different isotopes to see if changing their nuclear spin actually affects cognition. They even propose sending biological crystals into space to see if their quantum states last longer away from Earth's gravity. These are real experiments that could prove or completely falsify this entire idea. Which leaves us with this final, really powerful quote taken directly from the source material. Forget life as just chemistry and biology. What if, at its most fundamental level, life is a form of quantum vacuum engineering, a technology that evolved not just to survive, but to create a protected space where the universe itself can become aware?